Okay, let's say we ask to solve for x. Given that tan squared x equals 3 times the quantity of sec x take 1, given that x is within 0 and pi. Okay, tan squared x has the same as sine squared x over cos squared x, and 3 times sec x equals 3 over cos x, and 3 times negative 1, negative 3. Okay, so we want every single term in this equation to be something over cos squared x, so we can just cancel out the cos squared x on the denominator. Okay, so to do that, we can just, well, this first term is the same, since it is cos squared x on the denominator. This term here, 3 over cos x, if you times that by cos x over cos x, that's equal to 1, so the value doesn't actually change, but the denominator will become cos squared x. So we have 3 cos x over cos squared x. And the same goes here, we can just have 3 cos squared x over cos squared x. And we can just go like kaboom, kaboom, and kaboom out of here. Just put in numerators equal to each other. Sine squared x is equal to 3 cos x, take 3 cos squared x. This left hand side can be simplified. One take, well, actually converted, I should say, not simplified. 3 cos x, take 3 cos squared x. That's just a Pythagorean identity, like cos squared x plus sine squared x equals 1. So, distributing everything to one side of the equation, make it equal to 0. We have minus 3 becomes positive 3, take 1, 2 cos squared x, minus 3 cos x, left with positive 1 equals 0. And this is quadratic, we can just go like this, where x is equal to cos x, it's just trying to keep with the quadratic notation, x take 1 is equal to 0. So that implies that cos x, remembering that cos x equals x in this context here, that's been equal to 1/2, and for this bracket here, cos x being equal to 1. Okay, so this implies that x being equal to, well, within range of 0 and pi will have to be pi over 3. And here, this one is simple, x just being equal to 0. That's our solutions to this equation, and 0, done.